So here we go, the very last part of the notes in this unit. Solution stoichiometry, questions number 22 and 23. Let's get straight to it. Question number 22. What volume of 0.2 m HCl will react with 6.5 grams of magnesium? It gives us the beginning of the equation, but we have to finish it from there. You do need to finish the balanced equation, even though it seems like it's not necessary. It really is. So that's going to make magnesium chloride and hydrogen. And since that's MgCl2 and H2, we'll need a 2 in front there, which is what makes the balancing the equation so important. So what volume, question mark liters underneath the HCl, of 2 molar, 0.2 molar underneath the HCl, 6.5 grams of magnesium. So the ending part of this equation we don't actually need, except to give us the mole-to-mole ratio for the beginning. So I'm going to start with my 6.5 grams of magnesium. And the first thing I'm going to do with that is turn grams into moles. Off the periodic table, the molar mass of magnesium is 24.3 grams for every 1 mole. So that gives me the moles of magnesium, but I'm really looking for HCl. So, based on the balanced equation, 1 mole of magnesium is the same as 2 moles of HCl. So if I solve it, I get 0.535 moles of HCl. But we're not really looking for moles, remember we're looking for liters, so we're going to use the rest of the information with the molarity formula. 0.2 molarity is equal to 0.535 moles of HCl over X, and this will help us find the volume of HCl. When you're solving this, cross multiply, so that's 0.535 times 1 divided by 0.02, and you get X is equal to 2.67 liters. And that's my final answer. Last one, question number 23. Calculate the volume in milliliters of a 0.40 m molar HCl required to react with 20 milliliters of 0.25 molar K2CO3. First thing you need is a balanced equation. So that'll make KCl and H2O and CO2. And to balance that equation, I need a 2 in front of the HCl and a 2 in front of the KCl. Okay, there's actually 2 ways to do this, and I'm just going to do the one that I think makes easier logical sense to see, although it's not the fastest way. I'm going to start with this information about K2CO3, and then I'm going to move from that to HCl, and my last step is to get from molarity to milliliters. So I'm going to start with the fact that 0.25 molar K2CO3 is equal to X over 0.02 liters, because 20 milliliters is the same as 0.02 liters. And then I'm going to cross multiply. 0.25 times 0.02 divided by 1. And so I end up with 0.005 moles. Now that's moles of K2CO3. So now I'm going to change from moles of K2CO3 to moles of HCl. Using my balanced chemical equation, 1 mole of K2CO3 is equal to 2 moles of HCl, I guess will react with, which gives me a total number of moles of HCl as 0.01 moles of HCl. And now that I have that and the molarity, 0.4 molarity is equal to 0.01 moles of HCl over X. Cross multiply and divide by the 0.4. We end up with X is equal to 0.025 liters, which is the same as 25 milliliters. Now you can also use the dilution equation M1V1 is equal to M2V2, but you have to make sure to take into account the mole-to-mole ratio, the 2-to-1 ratio between K2CO3 and HCl. So I think that the way that I've done it right here is probably the easier way and easier to not get confused. Okay, that's it. That's all of our moles and stoichiometry and solutions and everything we need for this unit. Thanks for listening.